In our study of the general properties of the Mercator projection, we noted that scale is correct at the equator,
and elsewhere expands as the secant of the latitude.
As we move away from the equator, the scale expands. This means that the same number of centimetres of chart length represents fewer nautical miles of Earth distance, and the denominator of the representative fraction decreases. The ATPL syllabus requires you to be able to carry out Mercator scale change calculations. These calculations divide into four main types of problem. They are: given scale at the equator, calculate Mercator scale at some other latitude. Given Mercator scale at some other latitude, calculate the scale at the equator. Given Mercator scale at some latitude, calculate the scale at some other latitude. And given a fixed chart length between meridians, calculate Mercator scale at a specific latitude. The basic Mercator scale change equation is scale at any latitude equals scale at the equator
times secant of the latitude.
Let's now apply this to the first type of problem. Given the scale at the equator, calculate Mercator scale at some other latitude. Our worked example is the simplest way. Here's example 1. If the scale of the Mercator chart is 1 to 1 million at the equator, what is the scale at 60 north or south? Start with the basic equation and then substitute into it what you know. The rest just drops out. So, scale at any latitude equals scale at the equator
times secant of the latitude.
So what do we know? We're trying to find the scale at 60 north. That's the unknown. Let's leave it on the left-hand side of the equation. Do we know scale at the equator? Yes, we do. It's given in the question. It's 1 to 1 million, so let's put it in. Now, what about the latitude? It's 60 north. Put it in. However, that's not a very convenient form for us.
Firstly, we don't have a secant function on our calculator.
And secondly, representative fractions always have 1 as the numerator. So instead, write it as 1 over cos. Your calculator will tell you that the cosine of 60 degrees is a half. So we've solved it. The scale at 60 north will be 1 to 500,000. To reassure yourself that you haven't got your algebra upside down, you should carry out a common sense check. The scale expands as we move away from the equator. This means that the denominator decreases. In this example, the scale was 1 to 1 million at the equator, and it is 1 to 500,000 at 60 north. Using the standard Mercator scale change equation, let's now see how to deal with the second type. Given Mercator scale at some other latitude, calculate the scale at the equator. Again, we'll use a worked example. This is example 2. If the scale of a Mercator chart at 52 degrees south is 1 to 2 million, what is the scale at the equator? Again, start with the basic equation. What do we know? We know the scale at 52 degrees south. It's given in the question. It's 1 to 2 million. And, as before,
we can put in the secant of the latitude. And again, write secant as 1 over cos.
Rearrange the equation to make the scale at the equator the subject. And, remember from the lesson on basic scale, when evaluating a representative fraction, for easy calculator operation, divide the denominator by the numerator and then write the answer as 1 over the result. So, 2 million over cos 52 is 3,428,538. So the required answer is 1 over 3,428,538. Again, do the common sense check. We have come up with an answer where the denominator at the equator, about 3.5 million, is larger than at 52 north, where it's 2 million. Does this make sense? Yes, it does. The denominator should reduce as latitude increases. It's the right way round. The next type is, given Mercator scale at some latitude, calculate the scale at some other latitude. Again, we'll use a worked example. This is example 3. On a Mercator chart, the scale at 54 south is 1 to 2 million. What is the scale at 25 north? We could solve this simply by combining the previous two methods, a double substitution. Knowing the scale at 54 south, we can find the scale at the equator. Then, knowing the scale at the equator, we can find the scale at 25 north. And it would work, but there is a quicker way. We can instead use this formula. Denominator at latitude A divided by denominator at latitude B equals cosine A over cosine B. The basic relationship is that scale at latitude A over scale at latitude B equals secant A over secant B. However, scale, or representative fraction, is 1 over denominator, and secant is 1 over cos. With a little rearrangement, we get denominator A over denominator B equals cos A over cos B. Initially, we'll solve the problem the first way, the double substitution. This is useful anyway, because it'll confirm that the denominator decreases as the latitude increases. Then we'll use the new equation, and this should demonstrate how much quicker it is. We'll start by finding the scale at the equator. Scale at any latitude equals scale at the equator times secant of the latitude. The scale at 54 north is 1 to 2 million. As before, write secant as 1 over cos. Rearrange to make the scale at the equator the subject of the equation. This gives us the scale at the equator. It's 1 to 3402,603, about 1 to 3.4 million. Now, knowing the scale at the equator, we can find the scale at 25 north. Go back to the basic Mercator scale change formula. Scale at any latitude equals scale at the equator times secant of the latitude. We know the equator scale, so we can substitute in for 25 north. Multiplying out gives us a scale at 25 north. It's about 1 to 3.1 million. We'll just check that our solution is sensible. Draw a little sketch showing the equator, 25 north and 54 north, which is the same scale as 54 south. Write in the 3 scales we found. At the equator, it was about 1 to 3.4 million. At 25 north, it was about 1 to 3.1 million. And at 54 south, it was 1 to 2 million. Again, we've got the denominators decreasing as we move away from the equator. It reassures us that we've got our algebra the right way round. Now we'll use the equation involving cosines and denominators. As before, the question is, on a Mercator chart, the scale at 54 south is 1 to 2 million. What is the scale at 25 north? The basic equation is denominator at latitude A divided by denominator at latitude B equals cosine A over cosine B. However, rearrange it slightly to make the unknown denominator the subject of the equation. This gives us denominator A equals denominator B times cos A over cos B. Always put your unknown on the left-hand side of the equation. In this case, that's the denominator at 25 north. You know what the denominator at 54 south is. It's given in the question. It's 2 million. You can write them the other way around if you like, but it will involve you in more equation rearrangement and more chance of making a mistake. Put the unknown on the left side and keep it simple. You have now sorted out which one is A and which one is B. A is latitude 25 and B is latitude 54. Put them in. It now becomes a very simple calculator operation. 2 million times cos 25 divided by cos 54. It gives precisely the same answer as the other method, about 3.1 million. That's the denominator. Don't forget to write it down as 1 over in order to make it a representative fraction, which is what the question asked. This is a lot quicker than the other method. The last type of problem is, given a fixed chart length between meridians, calculate Mercator scale at a specific latitude. Again, let us look at a worked example. On a Mercator chart, the chart length between two meridians, 160 east and 160 west, is 30 centimeters at 30 south. What is the scale of the chart at 30 south? There are two ways of doing this, and there is very little to choose between them. The first is to treat it as a departure problem. Scale is defined as chart length over Earth distance. In this case, the Earth distance is the departure between longitudes 160 east and 160 west. Take the shorter departure between the two longitudes, in this case, the one crossing the Greenwich anti-meridian. In other words, the change of longitude is 40 degrees, not 320. Now substitute in what you know. The chart length is 30 centimeters, and the Earth distance is departure. The departure is change of longitude in minutes times cosine of latitude. The change of longitude is 40 degrees, and it needs to be multiplied by 60 to convert it to minutes. And the latitude is 30 south. This gives a departure of approximately 2,078 nautical miles. We now need to get everything into the same units, so we'll convert our nautical miles to centimetres. Multiply by 1852 to get them into metres, and then by another 100 to get them into centimetres. And then, as discussed in the lesson on basic scale, evaluate the denominator first and then divide by the numerator. When inverted, that gives a scale of 1 to 12,831,032. This method had little to do with Mercator charts and is essentially a scale and departure problem. The other method is to treat it as a Mercator scale problem. Find the scale at the equator as a normal representative fraction and then convert it to the scale at 30 south, like this. Firstly, find the scale at the equator. Write down the normal representative fraction equation. Representative fraction equals chart length over Earth distance. The meridians of a Mercator chart are parallel. If the chart length between two of them is 30 centimeters at 30 south, it will also be 30 centimeters at the equator. So, at the equator, 30 centimeters represents 40 degrees of change of longitude, and each degree of longitude is 60 nautical miles. So the departure is 2,400 nautical miles. Now get everything into the same units as before. Multiply the nautical miles by 1852 to convert to meters, and then by 100 for centimeters. This gives the scale at the equator as 1 to 14,816,000. Now we simply have a normal Mercator scale change problem, just like example 1. Scale at 30 south equals scale at the equator times secant 30. Substitute the scale at the equator, which we have just found,
and write the secant
as 1 over cos, and again we get the answer 1 to 12,831,032, about 1 to 12.8 million, just as before. There is a variation on the previous type of exercise, which appears to be more complex, but in fact is just as simple. As before, let's look at an example. On a particular direct Mercator wall chart, the distance between 180 degrees west and 180 degrees east meridians is 133 centimeters at 53 north. What is the scale of the chart at 30 south? At first sight, it seems that the solution is to find the scale at 53 north, and then do a Mercator scale change to 30 south. Many students will do this and will therefore waste time in an exam. The question is there to see if you can pick out the essentials. The point is that if the east-west chart length is 133 centimeters at 53 north, then it is also 133 centimeters at 30 south. On a Mercator chart, the scale changes with latitude, and the departure between two meridians changes with latitude, but the chart length does not. The meridians are parallel. Just solve the problem at 30 south. Find the departure between 180 degrees west and 180 degrees east at 30 south. That's 360 degrees change of longitude times 60 to convert to minutes, and then multiply by the cosine of 30 degrees, which is about 18,700 nautical miles. The chart length is in centimeters, so multiply this departure by 1852 and then 100 to get the Earth distance into centimeters as well. Now find the representative fraction in the usual way. The scale is chart length over Earth distance. Chart length is 133 centimeters, and we've just found the Earth distance. So the answer is about 1 to 26 million. So, to summarise, the ATPL syllabus requires you to be able to carry out Mercator scale change calculations. These calculations divide into 4 main types of problem. They are: given scale at the equator, calculate Mercator scale at some other latitude. Given Mercator scale at some other latitude, calculate the scale at the equator. Given Mercator scale at some latitude, calculate the scale at some other latitude. And given a fixed chart length between 2 meridians, calculate Mercator scale at a specific latitude. These are solved by one of 2 basic Mercator scale change formulae. The first is scale at any latitude equals scale at the equator
times secant of the latitude.
And the second is we get denominator A over denominator B equals cos A over cos B, which is often more usefully expressed as denominator A equals denominator B times cos A over cos B. Finally, there are problems where the chart length between meridians is given for a particular latitude. These can be solved either as a Mercator scale change problem or as a departure problem.